Hello, I am Paula Olea, part of the SMILE project, which is an European doctoral network on geoenergy. My research topic is to develop an integrated framework capable of monitoring potential environmental impacts in the extraction of underground brines in salt flats through Earth observation. Lithium has become a strategic resource in the global energy transition. It is a key component in electromobility. As countries move toward decarbonization, lithium demand has increased, being mostly extracted from brines. Brines is a very salty water. In Salar de Atacama is 10 times as saline as the ocean. Brine is pumped into evaporation ponds, potentially affecting the aquifer dynamics. Later, the concentrated lithium is stored in dumps, which can be seen in the picture. Salt flats form in arid environments where evaporation exceeds precipitation. Over thousands of years, water carrying dissolved minerals accumulates in depressions. When the water evaporates, it leaves behind extensive salt crust and highly concentrated brines beneath the surface. Earth observation is the technique of acquiring information about the Earth's surface remotely, mostly from satellite imagery. Instead of direct field measurements alone, satellites provide systematic, spatially continuous, and multi-temporal data. This allows us to monitor environmental dynamics over large areas and long periods. The methodology consists in integrate Earth observation datasets to perform an spatiotemporal analysis and integrating the previous results to obtain the interrelationships among the variables, considering in situ meteorological data and underground water level, as well as planetoscope imagery to validate the results. Ground deformation and vegetation analysis are the main evaluated components. Ground deformation could be considered as a surface expression of the underground water dynamics. For this reason, changes in the aquifer could lead to subsidence. On the other hand, vegetation is mostly located in the border of the salt flats, where brines meets fresh water. Vegetation indexes as NDVI are key to understand the vegetation dynamics. Changes in the depth of the aquifer could impact the dynamic of the vegetation. One of the most important lithium sources worldwide is the Salar de Atacama, located in northern Chile. This salt flat is part of a closed endorheic basin in the Atacama Desert. It is the size of the city of London. It is located in the driest desert in the world. It is 2,300 meters above the sea level. In the eastern part of the salt flat, the volcanic arc reached heights of over 5,000 meters above the sea level. In this study, we use satellite data from the European Space Agency Sentinel-1 and Sentinel-2 missions. Sentinel-1 provides radar data, which is particularly useful for detecting ground deformation. The first time series shows a stable area located in the east border. The second one in the center of the nucleus shows a relatively small uplift. The last time series, located in the transition zone, shows a continuous subsidence. For the vegetation analysis, Sentinel-2 and Landsat imagery were analyzed. 4 points have been selected to analyze the vegetation dynamics in one of the wetlands. The 4 points shows a change in the dynamic at the end of 2002, which could be related to some changes in the underground water dynamic. Also, some lower values are visible in 2007, which could be interpreted as flooding. Thank you for your attention, and don't forget flamingos every time you consider to buy a new lithium battery.